In this session, we want to talk about derived quantity, scalar and vector quantities. It's going to be a short one again because we are just doing introduction and we want everyone to have at least the understanding, the idea of what all these quantities are, because physics is going to be using them. We are going to use those quantities throughout, right? After looking at the base quantities, we realized that there were 7. Now, based on that, because they were fundamental, right? Let's look at the ones that are built from them. We said derived quantity, other quantities are obtained from the base quantities, right? Because the base are the foundation, right? So now let's look at those that we can use the base quantities to form. So the quantities that you can form from the base quantities, those are what we call the derived quantities. So we say derived quantities, they are formed from the combination of 2 or more of the fundamental quantities, right? So if you combine any of the fundamental quantities together, 1 or 2 or 3 of them, and then you are going to, once you do any combination of the fundamental quantities, you are going to have a derived quantity. Whatever is in that space is going to be a derived quantity. What are some of these examples of quantities that we can form? Yes, so these are the examples. So you can form a quantity called impulse, pressure, force, weight, energy, volume, area, velocity, momentum. There are many. As long as the thing, you know, there's 7 basic quantities, right? As long as you know the 7 base quantities, and there is a list of the other ones, a list of quantities for you to select from. Just know your 7 basic quantities. Anything that is not among the 7 is a derived quantity. That's how you can easily just keep it. Anything that is not the basic, right, is a derived quantity. So if you can see here, there is nothing of the basic quantity here. So all these quantities, they are all derived quantities. So because each of them is formed from the combination of 2 or more of the fundamental quantities, right? They are built from the combination of any of the fundamental quantities that we've done. So just know your 7 base quantities. That's why we took time to do a full video on that in the previous session. Only look at that and get the acronym of how to keep the fundamental quantities. Right? Once you know the fundamental quantities, anything that is not fundamental is derived. Now, that those two base quantities and derived quantities, we said in the introduction video, the very first video, that they are the quantities that are they are the classification of quantities based on the fundamental composition, right? What they are made up of, right? That's what we look so far. Now we need to look at the other type, because you say based on the value that we are going to obtain for a particular quantity. We also have 2 categories of the quantities. So that category, we mentioned scalar quantities. Scalar quantity is not a derived quantity. They are not focusing on derived quantity. Derived quantity and this base quantities are those that are the fundamental, very fundamental ones, very fundamental understanding of classification. But there are this group of things that is focusing on the value. So scalar quantities are quantities that can be represented by only their magnitude. So only their magnitude, right? There's no direction that will be entered here. So only the magnitude, that the magnitude is enough to represent the quantity. The magnitude is enough to use them to use the quantity. Only if only the magnitude is enough, and there is no way on earth that we can get the direction of that, then that particular quantity is a scalar quantity. And we have examples. And in the example, we made a note that all the 7 base quantities, they are all scalar quantity. They don't have direction, they have magnitude. They only have magnitude. So if they are saying that you should cite examples of scalar quantities, mention all the 7 fundamental quantities that we talk about. Yeah, and you are good to go. So yeah, those are the fundamental quantities that you need to know. There are 7. Those are 7 ones. I know if they want to ask you to cite some scalar quantities, and then they ask you about 10 of them, you have 7 in pocket already. But I doubt they even ask you 7. So yeah, that's why it's very important to follow the logic, right? You're talking about scalar quantities. These are quantities that can be represented. Only their magnitudes are useful to represent them. So we have other ones like energy, power, speed, volume, area, work. Yes, as an example that we can see, right? Yeah, those are the examples of scalar quantities. The other type of quantities that we will also want to explore is the vector quantities. So what are these quantities? These are quantities that is the opposite of scalar, right? This one is not only the magnitude that's important, we also need the direction in order to specify or represent this kind of vector quantities. Example, so they have magnitudes and they have direction, both of them, right? They have both. Vector quantities are quantities that can be represented by their magnitude and direction. So You don't just need the magnitude in this case, but you need their direction as well. Any of the quantity that has magnitude and direction is a vector quantity. Okay, so we have an understanding because we know that scalar quantity is only limited to magnitude, right? So when we are there, we are going to talk about only magnitude. But vector quantity is having both. So there are cases that we'll be looking at that. Okay, in such a case, even though a vector quantity has a direction, right? We might say, okay, now this guy has two of them. So in this case, in a particular case, we are going to be focusing on just the magnitude for the vector quantity, right? You might decide to focus on the direction, or you might decide to focus on the magnitude because it has both, right? That's how you can use this. That's how flexible you can use the vector quantity. Some cases will come that you just focus on the magnitude of the vector quantity. Some cases will come that you just focus on the direction, and then some cases where you need the two. But then the main difference is that vector quantity goes further ahead of the scalar quantity to have what a direction. So the difference between them is the possession of direction. Vector has direction, scalar does not have. So these are the examples of the vector quantity that we can have. Yes. So this is what we want to show you, and then this is just a bit of introduction. And so the examples that we have: velocity, acceleration, force, displacement, how they, what quantity they are made up of, what quantity they contain, will be in a separate video and a separate session for you to understand how they are obtained. But right now, for introduction sake, we just want you to have the basic idea. So these quantities, right? They are the common ones, and there are other common ones as well, but these are also common. So we'll use them in most of them. So just keep in mind that this particular quantity is a scalar, this particular quantity is a vector, and later we'll discuss into detail how to obtain and how to tell whether this is a vector or this is a scalar. We'll tell that later. But right now, it's very important to know common examples of the vector quantities. At least know the common ones. Know the common ones, and then also know the common scalar quantities. For the scalar quantities already, we say the 7 basic ones are already scalar. So yes, that's what we'll do. So in the next session, we'll focus on other things, especially unit, to see how it will lead us for us to grasp all the concepts. Remember, we are still gathering concepts, right, for the introduction for physics. Follow us in step by step so that you get this concept. Then when we start the major topics in physics, you don't find yourself wanting. Thank you, and see you in the next session.